In today's video, you guys will be learning about the different definitions of properties of special quadrilaterals. Thus far, we've talked about properties of triangles and specifically isosceles triangles and equilateral triangles. But now we're also going to talk about special quadrilaterals. So some of these you guys already know, but what I want you to do is take a few minutes to think about what types of quadrilaterals do you know. So just go ahead and type a list of names. And then we're going to discuss them on the next slide. All right, so a couple different types of special quadrilaterals. These first few I expect you probably were able to think about. So trapezoid, the one that's related to it that you probably think of as trapezoid, but is really a little bit more specific, is isosceles trapezoid. All right, and then we have parallelograms, rectangles, squares, rhombi. So you can say rhombi or rhombuses. And then the one that we don't think about quite as often and we don't actually always think of is a kite. And that is a type of special quadrilateral that most people don't know of or think about. All right, we're going to start with trapezoids. All right, so trapezoids are very simple and straightforward. All right, they have at least one set of parallel sides. Notice that it says at least. All right, and one of those things that we need to know is that the parallel sides are referred to as the bases. All right, so there are two different bases. They are often different sizes. All right, isosceles trapezoid, so it's similar to an isosceles triangle, but instead of referring to the sides, we're actually going to be looking at the angles. So the definition is that it is a trapezoid with congruent base angles. All right, so some of the properties that go with that is that we have consecutive angles are supplementary. All right, so consecutive angles along non-parallel sides to be specific, and the non-parallel sides are congruent. All right, so those non-base sides are congruent. All right, and that's very important. So even though just like with triangles, we don't associate the sides with the definition, it is also true. All right, now let's talk about parallelograms. So this is often one that we know a little bit about. All right, both sets of opposite sides are parallel, so that means we have two sets of parallel sides. So parallelograms are trapezoids. We're going to talk more about how they're related towards the end. All right, so in that diagram, I have my sides marked as being parallel. So some of the properties, all right, opposite sides are congruent. The opposite angles are congruent. Consecutive angles are supplementary. All right, so now we're going to talk about kites. All right, so kites are not part of that family. All right, so for kites, the consecutive sides are congruent. So notice the two next to each other. So AB is congruent to AD and DC is congruent to BC. All right, so in a kite, one pair of opposite angles are congruent, and that's the pair of angles where the two non-congruent sides meet. All right, rhombi. All right, so a rhombi, the definition is that all sides are congruent. All right, so four congruent sides. So some of those properties that opposite angles are congruent, consecutive angles are supplementary. So just like parallelograms. All right, rectangle. Rectangle is a quadrilateral with four right angles. All right, so some of those properties, opposite sides are parallel, opposite sides are congruent. All right, so a lot of these you'll notice these properties start overlapping, and we're going to get there towards the end here. Now we come to the square. All right, so square means four right angles and four congruent sides. So the square is all properties that we've talked about already. All right, so opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All of those things apply to squares. All right, and this is why. This is what we call the quadrilateral hierarchy. All right, this is the relationship amongst all of those quadrilaterals. So we start at the top with the very generic quadrilateral and we work our way down to the most specific one. All right, so you can see it starts by branching off into kites and trapezoids. All right, and a trapezoid branches off into parallelograms and rectangles. All right, and we can see that when I bring a kite and a rhombus together, a kite and parallelogram together, it's a rhombus. But when I bring a parallelogram and an isosceles trapezoid together, it's a rectangle. All right, and then when I bring that rhombus and rectangle together, so 4 congruent sides, 4 congruent angles, it comes together to make a square. So anything that towards the bottom, if it has a property, so if any property of a parallelogram is also the property of a rectangle, all right, or any property of a trapezoid is also going to end up being a property of a rhombus because it's below it, and they're all connected. All right, another way to think about this is, everybody hears that phrase, all squares are rectangles, but not all rectangles are squares. This is where we check that out. All right, so a square is a specific type of rectangle. All right, just like we can say that all rhombi are kites, but not all kites are rhombi. Or all parallelograms are trapezoids, but not all trapezoids are parallelograms. All right, so there's a lot of connections that we can make there based on this hierarchy. I would strongly encourage you to take some time to study this diagram, and we're gonna, take a deeper dive into it as we move on. All right, so that's all there is for quadrilaterals. We are going to talk a little bit more about some of the properties, specifically in reference to their diagonals, saving diagonals for a whole nother lesson. So, all right, take the time to look at the next activities and make sure you complete that quiz before you go into Delta Math to work on some of those practice assignments there.